I want to introduce a new machine learning model, decision trees. So what are decision trees? You could think of decision trees as like a game of 20 questions. So to play this game, typically it might go something like this. Okay, I'm thinking of a person. And somebody might say, is it a famous person? And you could say, yes. They say, is it a movie star? You say, no. Is it an athlete? And you say, yes. And the idea is that each time you ask a question, you narrow down the possibilities until you think that you can guess, in this case, the person, although it could be something else that your partner, say, is thinking of. So how does this work in machine learning? Well, you start off with your data, and in effect, each question you ask really splits the data into two separate groups. So if we're looking at the census data, whether somebody makes more or less than 50K, you might ask a question about their education, like are they a college graduate? And if the answer is yes, you group that data all together and the no's all together. Now, how are these splits determined, right? Well, it's just going to try some random ones out, and then the model will go back and sort of take the splits that give the best score either in that round or later on. Okay? Now, the idea of the decision tree is sort of like you can keep going with the splits. These are like the questions, kind of as long as you want. In the game of 20 questions, there would be 20 splits, say, at most. In a decision tree, it'll keep going until it converges or until a desired level of accuracy has been reached, okay? We'll talk more about when to stop the splitting a little bit later. Now, this is a real example of a decision tree in action. This is that census data set. So let's take a moment to look at this a little bit carefully. So if you look at the top of the tree, you can see that it's given this initial split, which is whether or not somebody is actually married, okay? And typically in columns like that, the result is 0 or 1, 0 for no, 1 for yes. And it's going to do the split kind of down the middle because it splits on floats. And basically what it says, class 0, this would be people who are not married. If that is true, then you would go down to this group. So that data would be split in this half. And the other data would be split in the right half, which is the false side. This splitting each time in the visual image is true for the left and false for the right. Now, you may wonder, okay, what is this Gini? Think of Gini as like probability. In effect, it's like the probability that what you have is correct. So let's look at the Gini at the very end. So if you follow down further and you say, hey, it's true, the person is not married, and then what's next? It's false. Okay, we're going to go to this side. It's false that the capital gain is less than 7,073.50, meaning they're making more than that. You arrive in this, you could call it a leaf because it's like the end of the tree here. And why is this the end of the tree? Because we can understand it better. It's been given a max depth of 2. So in a decision tree, you can set the depth, and a smaller depth definitely makes it easier to interpret. You could certainly keep going and make more splits. But if you stop here, then you can see that, look, in this particular case, wow, we've got a Gini. You could say it's like 6%. Alternatively, it's 94% correct, which is that the majority of people, are class 1, meaning they do make more than 50K. This makes sense. I'm not sure how influential this first split is, but the capital gain, certainly if somebody has a significant capital gain from this is like over 30 years ago, this data set, then it's likely that they make over 50K to high probability. And so this capital gain gives you the best probabilities. You can follow these other ones, and these are not the best results here. You can see they're kind of closer to 50-50. Okay. So that's sort of how you interpret a decision tree generally. And so just to highlight it, what you're doing is you're splitting the data each round. This is typically done by selecting columns and dividing it up by a number that splits the data in kind of an interesting way. The decision tree sklearn model has its own way of doing this. You can see it uses Gini, which is a probability scoring metric to sort of try to find optimal splits. Because there are, look, these are floats, these numbers, meaning decimals. You can split them in too many ways. You cannot find like perfect splits. Okay, that's simply impossible. There is too much to check. So algorithms are followed to try to find optimal splits until you reach at the conclusions. And the conclusions are the different leafs. And so when you're at the end of a decision tree, this would be like a completed model. And then you look at your data, you simply, like, let's say somebody is married, okay? So that would not be less than or equal to 0. Then they go here. And they have an education number that is greater than, say, 11.5. Okay, then that would be true, and they end up here. And then, interestingly, this predicts that they do not make more than 50K, which is a little bit of a surprise, although you can see that it is, in fact, close. But the point here is that you follow each row down to its prediction after the decision tree is built. So I would really think of decision trees as like games of 20 questions. This is a nonlinear machine learning model. It's going to split the data many times to try to kind of, you could say, partition your data to find a pathway to correctly predict the columns that you're trying to predict.